Okay, let me do a quick 5-minute intro. Good evening, everyone. Tonight's event marks the 6th anniversary of Serverless Toronto, and you might be wondering why we are focusing on Gen AI at the Serverless event. So, like many of you, I navigated through decades of tech evolution, and the last year I was fortunate enough to pivot into generative AI. And what I found is much, much bigger than any trend that I've encountered so far, including serverless. It's a seismic shift. So we are not just talking about a wave, it's tsunami that will transform industries, jobs, societies, especially as unemployment rates rise. And I believe that we have a narrow window, maybe 2 years before AI could potentially replace significant portion of our jobs. And that's precisely why we had tonight to extend the expiration date. So tonight you will gain situational awareness, like on this map of the battlefield, and you will learn to position yourself as the ones creating change, not just subject to it. And you will learn from the top minds. We are honored to have Mark Ryan, an AI lead at Google and the author of the book Deep Learning with Structured Data, and Jerry Liu, creator of LlamaIndex, the leading data framework for building LLM applications. So their insights will be practical, I can promise. They will offer strategies that you can apply directly to your teams and projects. And don't worry, we'll have plenty of time at the end for your questions during the Q&A portion. And before I give a microphone to our presenters, here's what this community is about and how definition of serverless has evolved over the last 6 years. So yes, we did start as a backend function as a service developers, gluing other people's APIs. But then we started helping UX folks and then product managers to create meaningful MVPs faster, which led to increased agility and bigger business impact. So we started to define serverless as new agile and the serverless mindset. And most of us IT professional engineers, as engineers, we like to engineer. So we tend to focus way too much on the tools rather than the things tools let us do. So we now define serverless state of mind, a way to focus on the business value. And I know it sounds fluffy, but it's simple terms. It comes to how you triage the problems in general. So if the platform has it, you use it. If the market has it, buy it. If you can reconsider the requirements, do it. But if you have to build it, then own it. And this reasoning can be applied to any tech stack. And also, if you're first time with us, I hope to see you again. Next month, the topic will be FinOps for those using AWS serverless stack. Yansu is one of the top voices when it comes to AWS cloud and was my mentor in the early days with AWS Lambda. And May meetup is a continuation of Gen AI topic because Pankaj Upreti, a community member and a friend, generously offered to share how he's using AI to grow his startup, not just for tech tasks, but also for marketing and business development. And I also believe that mastering systems thinking, which is holistic approach to problem solving and managing complexity, will improve the quality of conversational intelligence, both with AI for better LLM prompting and one another. So we are going to find you a great teacher on this topic. I hope Professor Joseph Kesser or David Shapiro will be with us this summer. I will keep you posted. And the last but not the least, I want to thank Manning Publications, who helped many of us get where we are today professionally through their high quality products at a reasonable price. And please do the survey to qualify for the raffle at the end of this meetup, bit.ly/SLSTO. So now let me pass the mic to our guest teachers, Mark and Jerry. We are honored to have you with us. Mark, you will go first to improve situational awareness related to AI and LLMs today. And then Jerry will go next and teach you how to solve core challenges in the rank pipeline. So thank you. Mark, please take it away.
Thanks so much, Daniel. I hope, looking forward to having a chat this evening on the subject of large language models and generative AI. So as Daniel said, I work at Google. I'll be talking in my own personal capacity tonight. Just to be clear, so I'm going to be talking about Google products as well as other products. And just to be clear about that, I'm the Developer Knowledge Platform AI lead in Google Cloud. And that means that I'm trying to find ways to take what I'll be talking about, to apply that within Google to make sure that the team working particularly on the documentation for the cloud AI products is as efficient as possible using AI. So what I plan to talk about tonight is starting with some milestones about generative AI. So generative AI is the overall topic. Large language models are an instance of that. That's dealing with transformer-based models, specifically doing with text. But generative AI includes things like dealing with image, with sound, with video as well. So I find that it's helpful when you're looking at trying to understand how we got to where we are right now to go over the history. So I'm going to take a little bit of time to talk about the history of large language models and generative AI more generally, and then talk about some of the tools and frameworks that have grown up around large language models, and wrap up by talking about what products the different vendors offer. So one of the challenges I had going through the history of generative AI is it keeps changing. In fact, I had to change these slides today because of some news that came up overnight. So it is a dynamic area. There's no question about that. So if you look at generative AI and say, well, where did it start? You can go back. People talk about machine learning and AI going back to the 50s, but really the start of the revolution that we're seeing now with generative AI was the Google research paper from 2017 called "Attention is All You Need." And this introduced the architecture of transformers. I'm not going to go into detail about transformers, but essentially what it does is provides, particularly for text, a way to identify connections between words that are far apart in the text. So models that existed before that, they would work with a certain proximity of words, but they couldn't handle connections in large pieces of text. And transformers provided a way of doing that. And the initial intention of this architecture was to make Google's translation, that is translating between human languages, better. It turned out that it was applicable to all kinds of problems and all kinds of solutions. So it's interesting, sometimes that happens in the history of technology. You have something that's designed to solve one problem, and it ends up being applicable to all kinds of other things. So in October of 2018, Google came out with the BERT model. So it's a transformer-based language model. And this was significant because it actually was something that was shared in open source. At the time, I worked at IBM. And I remember we hosted an instance of BERT on IBM Cloud. So it had a big impact even this early. But the thread that we're going to be talking about, it starts to kick off in February 2019 with GPT-2 from OpenAI. And OpenAI did something brilliant at that time. They said that this model was so good, it had such capabilities, they weren't going to actually release it to the public because it was so capable. Now, looking back now, going back 5 years, the limitations of it are really clear. But their press releases at the time created a lot of interest because they said, this is something that's just, we're being responsible. We're going to hold it back for a while because we're not sure just how much power we want to unleash on the world. But the thing that really started to get a lot of excitement in the technical community was GPT-3. And that came out in May 2020. I was lucky enough to get access to it in the summer of 2020. And it was really, really interesting to see what it was capable of doing. And I had been working in the area of machine learning for a while. I had never seen a model before that was as multi-purpose. So I'd be able to do experiments, all kinds of things, navigating London Underground, translating between human languages, generating Git commands from English, all kinds of things. At that time, it didn't do any of those things particularly well, but the fact it could even do those things was really remarkable. And at the time, I don't know if anybody else had access to it, it was a fairly developer-oriented system. And we'll see a little bit later in the story, OpenAI learned from that experience and how they opened up the technology more broadly than that. The beginning of 2021, DALL-E came out. This was an image model, so text to image from OpenAI. We'll talk a little bit more about image models in a bit. Google came out with Lambda. in May of 2021. That was the first of a set of flagship large language models from Google. Then in August of 2021, Codex came out. And this was a development of GPT-3 that was focused specifically on coding problems. So I mentioned before, when I got access to GPT-3, I did some experiments of going between different coding languages, and it wasn't that great. Because Codex was specifically tuned to work on coding problems, you could do things like provide a description of a simple website and get working JavaScript code from it. You could take code that's in one language and generate code in another language. Something that really interested me was the potential of taking COBOL and generating code in a more modern programming language from that. And I could see the progress from GPT-3 in the middle of 2020 to Codex in the middle of 2021. That really excited me. I thought this is something that shows a lot of promise for sure. DALL-E 2 came out in April of 2022, development of OpenAI's image model. May of 2022 was a big year, a big month. Google released Imagine, the image model, text-to-image model, as well as a new flagship LLM, PaLM, and DeepMind, which at the time was a separate entity with an alphabet from Google, released Gato, which was the initial kind of multimodal model, dealing with text and image at the same time. We'll return to that theme a little bit later in the story. And then towards the end of 2022, there was a huge flurry of models for text-to-image models. So Stable Diffusion, Midjourney, and kind of an arms race there. And this is something as well, you sort of saw the general public starting to become aware of the potential of generative AI, because it was a lot of fun. You could put in text and get a pretty good image. Looking back now, they look kind of primitive, some of the results from Stable Diffusion at the time, but then it was really quite impressive. So then everything settled down, and then, you know, not much happened in the year and a half since then, except for ChatGPT. The end of November 2022, this came out, and it was consumer chat. Now, the people who've been using GPT-3 were anticipating, like, what's OpenAI going to do next? When are we going to see the next flagship model from OpenAI? And there's a lot of, you know, kind of frustration, because a lot of time had passed. This is over 2 years had passed, and there have been developments in GPT-3, but nothing that was really groundbreaking. And when ChatGPT came out, it really was moving in a different direction. So this was a consumer chatbot, something that anybody could use, and was super simple to get access to. And I think it surprised OpenAI, the reaction to it. So it was the right sort of form factor at the right time, had huge popularity, and really became a kind of a front page story outside of the tech world. And I think one of the reasons that I'm here tonight, that we're talking about the topic of generative AI, LLMs, is because of the exposure that ChatGPT got. So it wasn't necessarily GPT-3, the model behind it, wasn't a huge leap from GPT 3.5, wasn't a huge leap from GPT-3, but the packaging and the way that it was made so easy to use really was a leap forward. So in February of 2023, Google came out with Bard, consumer chat experience. Then in March, OpenAI came out with its next flagship model, GPT-4. And this has sort of been a benchmark since then. As new models have come out, they've been compared to GPT-4. I'm going to talk a little bit more about those comparisons, and, you know, how people make decisions based on those. And there's a certain amount of mismatch between what's useful and what the comparisons say. But another interesting thing that OpenAI came out with at that time was plugins. So this was incorporating the ability to make calls to APIs in the context of a large language model. In April, AWS brought out Code Whisperer. So this was a coding assistant. I should mention, one of the things I didn't have on this timeline was GitHub Copilot. So that was another derivation of GPT-3, providing code assistance, text to code, in the context of GitHub. In May of 2023, Google incorporated generative AI into its Vertex AI platform. So the flagship AI and ML development platform in Google Cloud, including curated set of Google models, third-party models, and open models. And Google released a new flagship model, PaLM 2. In July, Meta came out with Llama 2. This is an open model, and this was significant because the earlier iteration of Llama had only been licensed for essentially for private use, for individual use or research, and Llama 2 was licensed pretty well for commercial use. And this was a big departure and really opened up a new thread of development in the world of generative AI. And at the same time, OpenAI came out with Code Interpreter. So this was an encapsulated coding environment within the context of ChatGPT. The neat thing about this is you could upload a CSV file and it would do basic data science sort of things. You get visualizations, some basic feature engineering incorporated within it, and you could run code snippets, Python code snippets in that context. I think this ended up being a little bit less of a revolution than was expected at the time. It got a lot of attention at the time, maybe hasn't been as much sustained interest, but at the time it was seen as something that was pretty important. In August of 2023, Google came out with Duet AI. This is an assistant for Google Cloud and Google Workspace, so generative AI in the context of Google Docs, Sheets, and within Google Cloud, and code assistance for general purpose code that's sort of turning text into code in the context of Python and Java and JavaScript, as well as SQL. And it also incorporated code interpretation. So you could take existing code and get the chatbot to interpret what the code was doing. The next iteration of OpenAI's image models came out in September. That's DALL-E 3. In November, a bunch of stuff happened with OpenAI, but we're not going to talk about that. I'm going to talk about Q. So that was a new chatbot from AWS, and Elon Musk's X organization released Grok. Then in December, Google released Gemini, so a new flagship model. This was multimodal from the ground up, so incorporating text, image, and video. Then in February, another set of models from Google, Gemini Pro. The interesting thing there was having an enormous context window, that is being able to have a prompt with a huge amount of text or up to 40 minutes of video, incorporated in the multimodal model. Google also came out with Gemma, which is an open model, the similar licensing to Llama 2. And the interesting thing about these open models is you can install them behind your own firewall. So they provide options for tuning and can do some adjustments to them that are not possible with the models that are hosted in one of the cloud hyperscalers. And OpenAI came out with Sora. So you may have seen news items about this over the last few weeks for their model going from text to video. And then I believe it was a week and a half ago, Anthropic came out with Claude 3, a new flagship model. I want to say a little bit about this. The stories talking about Claude 3, a lot of them had comparisons. So talking about benchmarks and saying, okay, here's how Claude 3 compares to GPT-4 or Llama 2 with these benchmarks. Now, when I look at that, to be honest, I think sometimes it's a situation like somebody says, look, I want to be able to go, I want a vehicle. I want to be able to go get groceries. I want to be able to take the kids to soccer games. I want to be able to, go visit the parents on the weekend. I want to have decent fuel economy. And I want it to start in the winter. And the benchmarks are sort of saying the 0 to 60 time is 3.5 seconds. And the drag coefficient is 2.3. Which is interesting, but it's not necessarily the use case most people want from these models. So it's be interesting to see how the marketing of the flagship models, if that changes, it becomes a little more oriented to how people actually need to use them versus the kind of speed and extreme usage. So using a Ferrari to go get groceries kind of situation. So we'll see what happens with that. And finally, the thing I had to add today is Devin. So Cognition made a big splash over the last 24 hours, talking about a model that does what they call it, automating the work of a software engineer. Now, I think there are a number of asterisks there. They've got some great demos that they've published. The benchmark that they talk about for Devin, when you look at the details, they're like 3 or 4 times better than the state of the art previously. So it was, I think it was Claude 2 was the example that they'd used of the software engineering benchmark that they were comparing it to. But when you look a little bit more closely, it's still only actually getting 14% on the benchmark. So of the 2,500 GitHub issues that are being put forward, it's getting a little over 10% of them right. So this is it's an interesting step forward, but it's not going to, in my opinion, it's not going to replace anybody's job anytime soon. So we talked about the history of large language models and generative AI, all the things that have happened over the last, I guess it's 7 years now. And in particular, in the last year and a half, it's just been a very, very dense set of announcements and things coming up. So one of the things that happened over the course of 2023 is you could see an ecosystem around large language models in particular coming up. Vector databases had existed before. So this is a way to organize data and the associated embeddings. That's putting data in a very high dimensional space. And they had existed and had a specialized use case, but because of the emergence of retrieval augmented generation as a way to kind of control or mitigate some of the shortcomings of large language models to get them to respond in ways that are grounded on a particular set of documents, that requires vector databases. So all of a sudden, vector databases became very interesting in the context of large language models. Encapsulated coding environments. So I mentioned Code Interpreter. That's been rebranded as Advanced Data Analysis. And this is a way to do ad hoc data analysis. One of the things, as I mentioned at the time, Code Interpreter made a big splash when it came out. I think the fact that it's dimmed a little bit since then is maybe a symptom of the fact that where OpenAI started from a generative AI point of view, and they've kind of grown over time to provide some of the services that would come from a cloud provider like Azure or AWS or Google Cloud. Whereas the cloud providers might already have these kinds of facilities. So that may be a reason why the encapsulated coding environments haven't taken off the way that they were expected when Code Interpreter first came up. On the other hand, plugins and extensions have had a lot of attention. So the ability to overcome things like when the large language models back in 2022, there was a lot of stuff about that they can't do math. So they can add 2-digit numbers, but not 3-digit numbers. And one of the ways to get around this is to make a call to an API, essentially give an LLM access to a calculator. So it won't try to do the things that it's not good at. It'll use an API to get those things. And for situations where large language models are particularly limited, or they need current data, or they need data that is past the data that they were trained with, being able to make calls to external APIs is really valuable. And then there are the application development frameworks, LangChain, LlamaIndex, and AutoGen. So providing a sort of an environment within which to create large language model applications. So before I wrap up, I want to talk a little bit about the overall landscape by vendor, because this is something that honestly, even working for Google, I can find a little bit confusing to say, well, what kind of class do these products fit into? This is by no means exhaustive. So there are other vendors. This is really more to do with things that I've been familiar with as opposed to trying to be completely exhaustive, but hopefully it'll give some kind of context for the different products. So there are the productivity suite assistance products. So this is incorporating AI in word processing, spreadsheet, presentation software. And Gemini for Google Workspace is an example of that, and Copilot 365 is an example of that. Then there's AI specifically aimed at developers or DevOps people. So Duet AI for Google Cloud is an example of that. GitHub Copilot is an example of that. And ChatGPT itself is used in that context as well. You can think of Q and Code Whisperer examples of that in the context of AWS. Consumer chat. This is something. I'd say it's a category that's kind of introduced by Google. So to have something that's aimed not at a professional enterprise audience, but at a consumer audience. So Gemini, which was the new name for what was called Bard, is an example of that. Bing Chat is an example of that. ChatGPT itself covers that. And for Anthropic, the Claude series of models can also play that role. For enterprise, generative AI, Vertex AI incorporates that. Azure OpenAI, ChatGPT Enterprise. AWS has a set of products that fit into that, Bedrock and Titan, particularly for models. And Claude 3, again, is aimed at both a consumer and an enterprise audience. Again, for sort of distinctions between the different audiences, Google has Google AI for developers. So this provides a way for people who, the area that I work in, Google Cloud, is meant for the enterprise, but people who are hobbyists, people who are students or solo developers can use Google AI for developers, get access to the Gemini model right now with an API key, and it's a bit of a simpler on-ramp to taking advantage of this technology. And ChatGPT plays the same role. And then finally, there are the open foundation models. So Google's Gemma is an example of that. Llama 2 and Mistral, the Mistral series of models from Mistral are examples of that as well. And as I mentioned before, the advantage of these models is you can install them on your own hardware, behind your own firewall, and you have a much broader set of options for tuning than you'd have in models that are curated on a cloud environment. So that's basically what I wanted to cover tonight. I know it's a very fast trip through the world of large language models, the vendor landscape. You can please connect with me on Twitter and LinkedIn. I have a YouTube channel that has some material from some of the experiments that I've done with GPT-3 and the other things I talked about tonight. So thank you very much, Daniel. I appreciate the opportunity to talk with everybody.
Thank you. I understand you will have to leave a little bit, but you will be back for Q&A.
No, actually, you know, I can stay. I didn't. The other
that's lovely. That's lovely. So save your questions until after Jerry's presentation. Thank you so much, Mark, for laying the landscape. So you couldn't see the slides when I just started, but it was the battlefield really to position you correctly to understand where you are now. And now Jerry's going to show you where the jobs are in the enterprises, at least this year, through the RAG pipelines talk. So Jerry, you're on mute. Thank you for
yeah, thanks Daniel for hosting. Thanks for the talk, Mark. That was great. And then excited to give I think this is like a 45-minute chat, and so we'll see how long this goes, and then do Q&A after. And yeah, feel free to feel free to send your questions. I'll try my best to answer it after the talk. Okay, let's get started. So the topic of this talk, and I've given variants of this last year, but actually, you know, what's interesting to think about RAG, especially since it's become like a predominant paradigm for building LLM apps within the enterprise, and also a lot of people are thinking about it, is what does RAG actually look like in 24? And for those of you who don't know what RAG is, what is RAG exactly? And so we'll cover the basics, talk a little bit about what it means to build RAG right now, and then look towards the future, right? And as Mark said, like there's all of these long context models coming out. As like AI advances, like what are we actually going to do in this space? How will some of these concepts emerge? What concepts will fade? And then, you know, how are we tackling that from the LlamaIndex side? So a brief overview of LlamaIndex for those of you who haven't heard of us before is that we are the data platform for your developers to connect LLMs on top of your data. So we have a very comprehensive open source framework to let you connect, you know, any of your data sources, unstructured, semi-structured, structured data, combine it with other popular modules in this AI ecosystem. So embedding models, LLMs, vector stores, evaluations, and data loaders, everything else. Into building all these Gen AI use cases. So all these LLM-powered use cases include question answering, structured extraction, conversations, and of course, agentic workflows. A quick refresher on this idea of RAG, right, or retrieval augmented generation, is that a lot of AI developers getting into the space are not only, you know, coming from an ML background where you're used to training the model on top of a data set, you're actually just taking the model as is in trying to figure out how to build an application around the model. So basically treating the model as a black box API and figuring out how to put stuff into the prompt, chain things together, do fancy things to basically achieve a given task. And so retrieval augmentation is one of these paradigms for basically augmenting a language model with external knowledge that it doesn't have access to beforehand. So if you're an enterprise, you have a large collection of PDFs or a private database, and you want the LLM to really understand it. A paradigm here is you basically you fix the model, you freeze it, you don't train it anymore, and then you augment the model with a vector database. So you dump all your data through some sort of ingestion pipeline into a vector database. I don't know why this is. Are you seeing a white screen as well? Stop sharing real quick.
Yeah, I have the same problem.
1 sec. Sorry about that. Yeah, so you dump your data into a vector database, and then you figure out how to basically feed that data into the input prompts. I am not sure what's happening. Are you guys seeing this white screen?
Yeah, we're seeing that too.
Yeah, weird. Okay.
Again.
Maybe just keep it out of slideshow mode.
Yeah, I'll try that. Give me 1 sec. Okay. And then, of course, there's a lot of discussions around fine tuning, and that's generally another technique for how do you incorporate knowledge into the network. Okay, I'm sorry, this hasn't happened before. I'm gonna let's see, I'm trying to think. I'll try one more thing. I am just going to share my desktop.
Maybe it's a Zoom glitch, like I had the same problem before.
Yeah, it was happening earlier with Daniel. It could be a Zoom problem tonight or
And
something.
I blame PowerPoint because I never used it before.
Okay, so I think you can see my entire desktop now. And nope, that is okay.
Crazy.
Let's see. I think it might be okay. How about this, Daniel? I'm gonna hop off really quick and hop back on.
Okay.
I'm just gonna restart Zoom.
Okay,
and
no
we'll see what
problem.
happens. Yeah.
Has anybody seen this problem before? Like, it's
You were able to see my slides.
Yes,
Okay.
and you were using which browser? I was on PowerPoint.
It was all Google. So not to say anything, but it was Chrome and Google Slides. So I tried to.
He's using slides.
Visual person here. All I'm saying is the Google stack.
He's using Chrome as well, I think.
If you look online, this problem seems to be hitting a lot of people. I haven't found a solution yet, but it seems like a common thing.
Thank you. So we'll be turning it off and on, like as you go with the slides. And then afterwards you can share the slide deck.
Yeah, I'll share the. Actually, here, how about this? I am just going to share this anyways, so that if you somehow it bugs out, you are just going to be able to.
I like that. So you can share the link here in the chat, like I did, but I realized that after my talk.
1 sec. Yeah. Okay. Okay. Cool. Let's get back to it.
Perfect.
So, let's talk about RAG. Oh my. Oh, okay.
We have the slides now, so anybody you can tell us, next, like sing along.
If you all have the slides, we're going to do this. We're just going to do a read along session where I'm going to read out the slide number, and then we are just going to all follow the slides one by one. I'm sorry about that. Yeah. Okay.
I'm sorry. I should have never left Google Meet.
No, it's fine. Yeah, I've been in a bunch of Zoom meetings. This is honestly the first time it's happened to me. Okay. So, slide 5, RAG. Slide 6. What is the current RAG stack for building a question answering system? And so what does retrieval augmented generation look like? It typically looks like 2 stages, data ingestion and parsing, as well as data querying. And so, you can set this up pretty easily in LlamaIndex, but basically the idea is to set up some sort of data pipeline to take data from your source into a database, and then set up some sort of query orchestration to load data from that database into the LLM's prompt. Slide 7, the data ingestion and parsing piece, especially a very basic stack, typically looks like the following. You take in some documents, like some PDFs. You split these documents into even chunks, where each chunk is a piece of raw text. You generate an embedding for each chunk, for instance, using one of these many embedding models out there, and then you store the chunk into a vector database. Slide 8, the current RAG stack for querying is once you have a data in a vector database, you typically do two things. Slide 9, retrieval as well as synthesis. So retrieval, you find the top K most similar chunks from the vector database collection, and then you the synthesis piece is you basically dump all that data into the LLM input prompt. And so it's honestly pretty primitive. You just take in all this text that you loaded from the vector database, you do some sort of retrieval pass to fetch that data from that database, and then you just stuff all the text into the prompt window of the LLM, and then expect the LLM to figure out the right answer given that retrieved data. We're now going to jump ahead a little bit to slide 13. So challenges with naive RAG. One of the common threads that we talk about is slide 14. Slide 14 is one of the common threads we talk about for RAG is the fact that for a lot of cases, when you set something up, especially for all the AI developers entering into this space, it's very easy to follow like an online YouTube tutorial to get something basic up and running over like a document or two, especially if you're building RAG over this very small set of data. But it's very hard to scale up and productionize. And so let's dig into a little bit what the challenges of actually building a RAG system are. The slide 14 shows you, the data parsing and ingestion as well as data querying, where you have like a data pipeline going from data to the vector store or index, and then the data querying pipeline. Slide 15 shows you what a basic naive RAG pipeline would look like. So, from your source data, you might do some very basic document loading, data parsing and ingestion. And then you might do some light sentence splitting on top of that document. So if you go put it through like an open source PDF parser like PyPDF, you're going to get back some extracted text, do some sort of naive chunking algorithm, put it into a vector store right here. And then the dense retrieval is after it's in the vector store, you're going to do some very basic retrieval algorithm on top of that vector store and do a very simple question answering prompt. And this will give you, a rough, very naive chatbot. And so slide 16 is these approaches tend to be very easy to prototype, but they're hard to productionize. When you set something up, by following these starter tutorials on the internet, these RAG approaches tend to work well for very simple questions over a simple small set of documents. For instance, if you ask like, what are the main risk factors for Tesla? Or what did the author do during his time at YC? Like these are all very basic questions over simple data sources where the answer is typically found in a fact or two within the document. And so for that type of stuff where you're just like retrieving a piece of information to answer a question, naive RAG actually works pretty well, right? And I think that's one of the appeals of it is that you're basically able to set up very simple document search very easily on your own without having to resort to some out-of-the-box search system. In slide 18, we're going to see that the issue is that productionizing RAG over more questions and a larger set of data is very hard. And so some of the failure modes that you might run into once you actually try to, make this a production quality application internally or externally is response quality, the lack of ability to really improve your pipeline, and then also systems level considerations, high latency, cost, and low security. Slide 19, some challenges with naive RAG, in terms of digging into the response quality issues is one of the first things is bad retrieval. So you might face one of the first things that you face when you actually set up a retrieval pipeline is that this top K embedding lookup, this thing where you retrieve information from a vector database is insufficient to actually give you the context that you want. And there's different symptoms of this. Like sometimes you return a lot of irrelevant information. Sometimes you return a lot of information that you don't return the relevant information. And either way, when you return basically bad quality data, so your retrieval is bad, then it doesn't actually matter how good your LLM is, you're going to get a bad result because a language model is just not going to know the right answer to the question. There's also just the qualities of the LLM itself. Obviously, as models get better, this is slide 20, by the way, models might end up, like as models get better, some of these issues around like hallucinations and not being able to pull apart information within the context, that those issues might go down. That said, especially if you're using like open source models or models that need to reason over large amounts of context, you still might run into hallucination issues. The model might, make up an answer that isn't in the context, as well as relevance and toxicity issues. Slide 21 basically talks a little bit about what the difference in building LLM software is versus traditional software. So traditional software is typically defined by a set of programmatic rules. So given an input, you can easily reason about like the expected output. Because you as the programmer, you're writing a bunch of these functions, you can easily reason generally what the output should look like given the input, and you can easily write the unit test for that. Slide 22 shows that AI-powered software is defined by a black box set of parameters. And because it's basically just a giant neural net trained over some data, even if you know what the parameters are, it's really hard to reason about what the function space looks like. These types of models can basically take in any text and spit out any text. And it's basically impossible for a human to really understand what the model looks like by just looking at the weights. And so the issue is that when you plug this thing into this overall system, then all of a sudden, it adds this key black box element within your software. Slide 23, the point is that if you add something that's very black box and complex into your software, then if one component of this is that complex black box thing, then all the components of the system become like a black box. Because now, when you set up a RAG pipeline, you're not only setting up the LLM, you're plugging it into this overall retrieval system, which is powered by this data ingestion pipeline. All of these come with parameters. Like the data ingestion pipeline comes with some sort of parsing strategy, chunk size. The retrieval algorithm has its own parameters, like the top K value, whether you do dense search or not. And as an engineer, you basically have to cobble all these things together around an LLM to build your application. And the issue is that all of these, slide 24, become part of this overall system like RAG, and it's really hard to reason about each parameter in isolation because every parameter here actually affects the performance of the end system. Your chunk size will eventually affect the chunks which get sent to the LLM, which affect the output response quality. Your retrieval strategy, of course, affects the output response quality as well. And so you basically make the overall problem more complex because all of a sudden you have a lot of parameters that you need to tune that are outside the model. And slide 25 articulates this just more explicitly. There's a lot of parameters for developers to figure out. Every parameter affects the performance of this RAG pipeline. And if you're trying to tune a RAG system to be better, there's just a lot of things that you can try out. And so, starting from the data to the data parsing and ingestion strategy, you can think about what PDF parser should I use? How do I chunk my documents with the right chunk size? How do I process like these complex documents with embedded tables and charts? What embedding model should I use? What retrieval parameter should I use? And all of these things affect your final response quality. Slide 26, mapping pain points to solutions. Slide 27, one solution to this is that you can try to really distill down some of the key pain points in building RAG. And this is inevitable. As more and more people build RAG, it's not like people are just completely flying blind. Best practices will inevitably emerge. And then people will start to put out these educational resources like us in terms of like really understanding what are some of the key issues in building this and what are some of the best practices you can undertake to try to solve this. So if you categorize by pain point and establish best practices around each pain point, you can basically have some sort of cheat sheet where you as the AI engineer are able to map out different types of solutions depending on the issues that you're experiencing. And so Slide 28 is, there's this recent paper that just did a survey of like overall failure points when engineering a retrieval augmented generation system. And then slide 29 is, by one of our contributors / collaborators, Wenqi, who's now a solutions architect at NVIDIA. And I think she was supposed to be giving this talk, but I'm actually helping to take over for this. So actually a lot of this material is stuff that she would have gone over anyways. And basically Wenqi expanded this into an overall general set of RAG pain points, and not only outlined the pain points, but also mapped out the solutions to each pain point. And the nice thing about having a framework like LlamaIndex, right, as an open source toolkit, is you basically have a very guided approach towards building out the right solutions for each of these pain points. I think maybe for the purposes of this, I'm actually not going to go through all the pain points, but I'll just articulate them at a high level. And so for slide 30 is, in general, if you look at the entire sequence of like RAG, from data indexing to retrieval to synthesis, there's a lot of things that might pop up in terms of issues. And so the first is that the data itself might not be ingested properly. So it's like the garbage in, garbage out paradigm. If your data itself is represented wrong, then you're just not going to have a good time when you build a RAG system. The second is 2 through 7 just deal with the overall query pipeline after the data is stored in a vector database. The context might be missing during the initial retrieval pass. The context might be missing after re-ranking, a popular step in retrieval systems. The context might not be extracted at all, so that the LLM isn't able to read the context, even though it's been retrieved. The output might not be generating the output in the right format, or the LLM might be reasoning over incomplete context, so it can't actually give you the output that you want. Some other general pain points that users deal with is like scalability, not being able to scale to larger data volumes, running into rate limit issues. Security, being able to defend against stuff like prompt injections, and then kind of being able to actually build advanced RAG for specific use cases. And so, for instance, being able to do question answering over CSVs or tabular data or big tables. And then, one of our favorite use cases is basically how do you actually, again, do RAG over a bunch of PDFs. And these PDFs can be very complicated. There's a lot of different sections, images, charts, and basically a bunch of stuff in there where naive RAG actually doesn't do very well. So I'm going to skip everything in the solution slide. You all have the material, so I am going to skip that really quick. And then maybe a quick note on if we jump ahead all the way to slide 49. So LlamaParse. This is just a quick plug. We basically launched this in private preview a few weeks ago. And then we also just did a more general announcement today. So that's self-serve for everybody. But LlamaParse is a Gen AI native parser designed to let you build RAG over complex documents. It extracts tables from PDFs, but it's actually not the only thing that it does. I'm going to actually go over the capabilities in the next slide. But it's basically a Gen AI native parser to let you connect your data with LLMs, and it's very, very good at understanding your complex data. Slide 50 outlines some of the capabilities. It's able to extract tables and charts. It lets you input natural language parsing instructions, lets you output stuff in JSON mode, extract out images, and has support for 10+ document types. And 52 shows some basic results for LlamaParse, and you're free to click into some of these results to really understand and take a look. But we were obsessed with this problem. How do you actually build RAG over these PDFs with a lot of tables? And we compared against a lot of these other PDF parsers out there, and also directly integrated LlamaParse with our framework. It would basically show, having nice solutions around the data parsing is actually a key ingredient to help you build performant document RAG. Okay, let's go to slide 55. Let me see if I can actually do something real quick. I'm gonna just roll the dice and then try sharing my screen again. And then if it doesn't work, oh, you disabled screen sharing, all right.
I can enable it again, but looks like we had a spammer. Somebody was trying to share the screen or whiteboard. So
Can you enable it just for Jerry?
Yeah, so let's,
Oh,
John,
oh,
tell
I
me how
see.
to do that.
Oh, sorry to hear that. Okay.
No, so is it whiteboard? I will enable
Yeah.
it again. Okay.
No worries. If it takes
All
too long,
participants. So I enabled it. Can you try again? So whiteboarding is enabled. And then security, screen share is enabled again.
Yeah.
Can you try that?
Yeah, let's do that.
So we were hacked. It looks like that was the reason for the weirdness.
I see. Interesting. Okay. Cool. Well, fingers crossed. All right. What's next? Okay, never mind. I see a white screen again. Okay. That is okay. I am just going to go into maybe if everyone just follows along with the slides again, we can just go to slide 55. Okay, so picking up from where we were before, slide 55, what's one aspect of what's next for RAG is agents, right? And I'll just do a really quick overview of it kind of like how we think about agents and RAG and how they fit together. Slide 56 is, we have these retrieval augmented generation pipelines. Let's say a user has set them up, and what it's capable of doing is taking in a question and generating an output answer. Of course, at the same time, a lot of users are also very interested and fascinated with this idea of, having LLMs become like agents and actually automating away a lot of the workflows that, depending on your role, you would typically do, whether you're in customer service, whether you're a software engineer, whether you're like a knowledge worker and you want to extract out a bunch of information. There's a lot of promise for how do you think about agents. So slide 57, if we think about thinking about the progression of RAG to agents, what does that actually look like? If RAG is really a pretty simple thing to do, you just put stuff in a vector database and the LLM doesn't really come in until the end of that process, where it just synthesizes information from your vector database. But there's a lot of opportunity to basically use the LLM at every step of this process in a repeated manner to not only just do synthesis, but also reasoning over every input task that you give it. And so the idea of an agent is pretty broadly defined, but at a very high level, you can think about having agentic reasoning before a RAG pipeline, in the middle of a RAG pipeline, as well as after. We define agents, honestly, with a pretty broad definition, slide 58. We just define it as using LLMs for automated reasoning and tool selection. And so RAG is just one tool. Agents can decide to use RAG. They can decide to use web search. They can decide to use a SQL database. And the whole idea is that in a world where LLMs are communicating with each other, where they're accessing these external data interfaces, where they're able to synthesize information and perform actions for users, this is basically where we think agents would fit. So there are simple levels. There are different levels of agents, from very simple to advanced. The simplest example of an agent is just like a router or a one-shot query planning prompt. And we can talk a little bit about what that means, but these approaches tend to be a lot simpler, so they present lower cost, lower latency. They're easier for these weaker LLMs to handle. They typically won't be able to handle very complex queries or help you solve very broad use cases. There's a lot of research, of course, in terms of using agents for just higher order, like LLM as an operating system type planning, execution, and tool use and decision making. And that's where you get all these kind of fancier agentic paradigms, right? And so I think we were talking about a little bit about like Devin that just came out. And I think one of the cool use cases of Devin was the fact that it's able to automate not just your coding workflow as an initial co-pilot, but actually help you do the end-to-end process of something. And so I think we're going to see more and more of advanced agents come out where users can basically trust agents to automate more and more of their tasks. I'll first talk a little bit about the simplest form of agents, slide 60, which is routing. Honestly, I think routing is just a very simple concept, but it's actually a very powerful one. It's basically just a prompt where, given an input task, you can decide what multiple choice thing to pick given the input prompt. So if you're given like 2 choices or 4 choices or more, given some sort of input, you're able to decide which of these choices are relevant to the input and decide to execute that choice. And so a very basic example of how this applies to RAG is assume you have like 2 different like RAG pipelines. One is designed for vector search, and so you have a top K of like 1 or 2, and for lookup of specific information. And the other is designed to load in like an entire documents into the context window. That is obviously going to be slower and more expensive, but is obviously better for certain types of questions that require synthesis across the entire document. With a router, you can actually design a query interface where you can dynamically choose which underlying pipeline to use given the properties of the question. And so I think that's one of those things where you're actually able to use the LLM to create a more dynamic query interface that is more general and capable of reasoning about different types of questions. We're going to skip ahead really quick to slide 68. Where we're going to go all the way to what kind of like a common agent pattern is once it's actually more fully built out. And so in LlamaIndex, we call these data agents. And so if we start off with a very basic ingredient of just using LLMs to do basic tool use, query decomposition and routing, and then also add in a loop in conversation memory, you have a more fully built out agent architecture. And so a typical like agent these days looks like something like the following. You have a set of tools. So you have, say, like a set of pipelines or query engine tools or just external tools. So this not only includes like a query pipeline, this also includes like web search. This includes being able to a Gmail tool, Google Calendar tool. You can actually send an email, schedule a calendar invite, and a variety of other things. So an agent has access to a set of tools, and the agent itself is just a reasoning loop over the set of tools. And the agent is augmented with some sort of thing that can manage state for it. And this is typically like a conversation history memory, but it has a light resemblance to just some initial aspects of computer architecture, right? Like the agent reasoning loop is basically the processor. This idea of memory is basically RAM. And it can decide to, of course, process these things, perform actions given the tools or applications that it has. Slide 69, a very popular framework that came out in 2022. And one of the first agent paradigms was this idea of React, which is basically taking chain of thought reasoning and interleaving it with tool use. So given a question, the LLM can break the question down step by step into smaller questions, and for each question, decide what tool to use to best solve that question. It's actually a pretty flexible general paradigm, and I think most people building agents probably start off with React because it actually is probably the cheapest thing that you can implement, and it will not be able to do very long-term sophisticated query planning, but for initial tasks where you want the agent to do something, a very small set of steps well, then React is actually a pretty good approach to doing that. Slide 70 just shows you an example of using a React agent on top of like a RAG pipeline. So let's say you had a RAG pipeline for different cities. So here there's just Houston, Chicago, and other cities. And we just index the Wikipedia page of these different cities. If you ask the agent, tell me about the demographics of Houston and compare that with the demographics of Chicago, then the React agent will break this question down into smaller steps. Tell me first look up demographics in Houston, get back the answer, and then look up demographics in Chicago, get back the answer, and synthesize the result for you. Skipping ahead to slide 72, thinking about just like long-term, what are people doing with agents these days? Can we make this even better? And so one idea is basically, instead of just doing chain of thought processing, actually have agents do longer term query planning where it's able to define an entire outline of steps. So plan ahead an entire sequence of steps and know how to execute all of that in greater batches than just a batch size of one. The second is how do we actually take advantage of parallel execution? For instance, if you need to do 5 things at once and they don't actually have dependencies on each other, you can try to just execute all of them at once, and you take advantage of parallelism. Slides 73 to 76, 75 basically go over some of the kind of initial approaches towards more complex agents. Keep in mind, a lot of these more complex frameworks typically have greater cost and latency than something that's React-based, just because some of it involves like simulating out multiple steps, planning out an entire DAG. And like by doing that, you're able to have more rollouts, which gives you greater information about the value of each of these rollouts. But in general, it's going to be a little bit slower. Of course, as these models get better in terms of reasoning and also their cost and latency go down, some of these approaches will be more feasible to implement in a practical setting. Great. I think that's basically, there's another section, but I know we're at 4:15. And the last section was basically, if we go to slide 78, basically another future direction for RAG is just thinking about the interaction of RAG with long context windows, especially with recent models like Gemini Pro, Claude 3, and more. And so there's some thoughts here that I'm happy to go over, but we can also go over it during Q&A. So checking with you, Daniel. Oh, I think you're...
Oh, we don't hear you, Daniel.
Yeah, I have double mute, so feel free to continue. Like, we still have time. That was a rough agenda, like 45 minutes, and looks like people are clapping, so this is a hot new topic.
Okay, sure, yeah, it seems like people are interested. So, okay, slide 78. What's next for RAG in terms of long context windows? There were a bunch of threads basically asking whether or not RAG was dead. And so I think, if you go to slide 79, once Gemini 1.5 Pro came out, I think people were really excited by it and also asking these questions because 1.5 Pro has a 1 to 10 million context window. And I think Francis, or Yao, he's like a researcher who I think is joining Google actually, basically had this like very popular and spicy tweet thread, which was basically saying a lot of RAG is dead because long context will replace RAG. And so what does this actually mean, right? Like if we just think very practically speaking, what parts of RAG will likely go away and what parts of RAG will stay? And the whole idea of RAG was to try to index a larger corpus of data. But if you have a larger context window, like 1 to 10 million tokens, and you can just shove a bunch of documents in there at once, then it is a valid question, right, to address. So slide 80 is the first thing, which is more just like inward facing, is LlamaIndex is not just a RAG framework. LlamaIndex is an LLM framework to help you connect with your data. And so RAG is just a current way that people are extracting insights from their data. But whether or not RAG lives or dies, we are going to build all the new use cases that these models enable. This includes agents. This includes any new use cases that we haven't thought about. This includes still being able to connect to large amounts, gigabytes, terabytes of your data, and figuring out how LLMs can interact with the service. Position number 2 is, okay, now that we said that, I think, just very practically speaking, I do think certain RAG concepts will probably go away. I think in general, it'll be a net win for developers so that, you have to figure out a little bit less stuff. That said, you're not really solving all the issues of large data processing, and others will remain and evolve. And so, if you think about a long context LLM with 1 to 10 million tokens, you have something that needs to, like, if you have gigabytes of data, for instance, you still need to figure out how to like take these gigabytes of data and put it into the context window and make the best use of the context window. So slide 81 goes into this a little bit more. Long context LLMs will solve the following. I do think in the long term, developers will worry a little bit less about tuning chunking algorithms. So right now, you're taking a long document, slicing it up into a bunch of chunks. And part of the reason for this is that you can't just shove the entire document into the context window. And so, in the future, you might be able to. You might just actually just be able to shove entire documents into the context window. Number 2, developers will spend less time tuning retrieval and chain of thought over single documents. I think this piece is one of those things where, like, I feel like right now, because of the current context window limitations, you're really trying. There's a lot of these like papers that are basically augmented or advanced RAG, where you're basically trying to hack the retrieval algorithm to give you a little bit better context than doing some back and forth with vector database, and making use of that limited context window to still generate a good result. If you just have like a 10 million context window, you probably, like a strong baseline is to just do dense retrieval and just set your top K to like 100. So you just fetch like a bunch of stuff through pure embedding search, and it doesn't really matter as much if your precision isn't very high. As long as roughly some context is in there, you can just like throw as much stuff as you want into the LLM. General document summarization and comparisons will be easier to do. One of the issues with naive RAG, which I outlined in the very beginning, is it's only very good for answering questions over specific facts. If you can throw entire documents or pairs of documents in there, then you can easily compare between different documents, summarize them, do more advanced analysis than actually just asking the LLM to reason over more limited context. And personalized memory, like conversation memory, will probably be better and easier to build. Some general challenges still remain. I think one is like 10 million tokens is not enough for most large document corpuses that are in the hundreds of megabytes, gigabytes. If you have a lot of unstructured data, if you have a lot of structured data actually, and you have a lot of stuff in between, you still need to figure out how to generally tackle this problem of feeding this data into a language model. Second is, if you want to do retrieval at all, embedding models are lagging behind in context length compared to the LLM. And so the context length like of the embedding models isn't keeping up. So you can't just generate an embedding across like a 1 million token document. Third is like cost and latency, which, doing inference on like 10 million tokens is pretty expensive and also pretty slow. This will almost certainly come down over time. And the second point that is this idea of like a KV cache, where you can technically cache the activations of like a 10 million token document, so that basically in your next inference call, you don't need to rerun all the activations for those 10 million tokens. That said, that in itself has some research issues. A KV cache takes up like a lot of GPU memory and has sequential dependencies. And it's actually pretty hard. It's not really the same as a traditional like computer cache. It's really hard to think about how do you like put stuff in and evict from the cache in a proper way. So assuming that, and there's like other challenges too that I could name, but like generally speaking, slide 83, assuming that like you're still going to have a large amount of data, whether it's structured or unstructured, you still need to do some sort of retrieval. And third is assuming like cost and latency are still generally things that you're worried about, especially as you want to serve this to a lot of different types of end users, then it's interesting to think about like what new RAG architectures will emerge. We outlined 3 right here, which is small to big retrieval over documents, intelligent routing for latency and cost trade-offs, and retrieval augmented KV caching. A lot of this is more long-term facing. 1 and 2 we basically have right now. 3 is more of an open research problem. So slide 84, small to big retrieval over documents. One of these things, first of all, like what does this mean, right? And what this means is, let's assume that retrieval is still necessary. Like, let's say you still have too many documents. Let's say you have like 100,000 documents or something. So you can't just dump all 100,000 documents into the context window. So you still need to do some sort of retrieval, but you don't need to chunk these documents anymore. If you retrieve a document, you can just like put the entire thing in the context window, and you don't need to return small chunks. And so you can definitely do that, but the main issue is now you need to generate an embedding for that document. And because embedding model context sizes haven't quite caught up, and oftentimes even disregarding that piece, it might not even be ideal to only have one embedding representation for the document. It might make sense to have multiple embedding representations for the same document corresponding to semantic context in the document. And so when we talk about small to big retrieval, we mean that we actually decouple the retrieval process from the synthesis piece a little bit, so that the data used for retrieval, for indexing, is actually very small. Think about it as like concise summaries or small chunks of the document. But the final thing you feed to the LLM will always be the entire document. And so this is actually already in the framework, and it's actually a pretty popular approach for improving your RAG performance. You index the document with a bunch of different embeddings corresponding to small chunks, but then before you actually feed it to the LLM, you retrieve the entire document text, and then you feed it the entire document into the LLM. The second thing is just intelligent routing for latency and cost trade-offs. An overall way of thinking about long context LLMs is they introduce just another point in this overall basket of performance and latency and cost. So, obviously things that have high latency and cost tend to give you better performance. Like if you are able to throw in like 10 million tokens into the LLM, you're going to be paying some amount of money, but you also get good performance. If you're running like a Mistral 7B or even a smaller model and you're loading a small amount of context, it's going to be much faster, but it will probably do less well. So depending on the type of question you want to ask, it's very interesting because I think for many tasks, you really don't need to shove like massive amounts of context into the context window. You can still stick with like smaller chunk sizes. And this does have benefits in terms of latency and cost. And of course, for more complex research tasks, you might very well want to have RAG pipelines where you are able to do like large scale like multi-doc retrieval. And depending on the question, like going back to this concept of a router, you probably can have some sort of intelligent router that, depending on the question and depending on how you like fine tune or prompt this router, can really dynamically decide which pipeline to go to based on the complexity of the question. And the last thing I'll talk about before we conclude is just this idea of like retrieval augmented KV caching. The KV cache, again, is just a mechanism for caching the activations. So if you like load in a large document and you do chat over it, you don't need to send the entire document back into the LLM over and over again. I think this is less of a concrete formed idea and more of a general thought is like, if you still have a large document corpus that's in the gigabytes or even terabytes, thinking about this idea of a KV cache and then thinking about this idea of like external storage is basically similar to like a CPU or a computer architecture, where you have like, for instance, some sort of LRU cache, like L1 cache to like RAM to disk, all these things. There's some sort of like memory hierarchy where like the stuff that's like most easily accessible will be the fastest, but will be relatively expensive, and then stuff that is not as easily accessible will be a little bit cheaper. And so figuring out how to properly do retrieval to load documents into this cache so that the user is likely to converse with this relevant set of documents, and then figuring out some sort of eviction policy, I think that is actually going to be very interesting. It's not a well-formed idea though, because, and this gets into a lot of technical details, this KV cache doesn't really behave like a normal cache. And so it's actually, this whole thing is a little bit up in the air as to the API interface. But anyhow, thanks for taking the time. Sorry about the slides, and yeah, open any questions.
Thank you so much, both of you. And I apologize, we had a hacker in the system, so I keep having to remove them from the group. So let's open it to Q&A. Feel free to unmute yourself. And then, hello, can you hear me? I'm on mute.
Hello.
Hi.
Can you hear me?
Yes, yes. So
Hi,
feel
great
free.
talk. Yeah, thanks, Jerry, and thanks for organizing, Daniel. It's great. So my question is like, so how does the LLM find the answer with like the RAG, So does it combine the knowledge it learned during the training and the content of the external document, or it is smart enough to just get the answer from the external document if you tell it to do so?
Yeah, so the whole idea of RAG is that the LLM does not know the knowledge during training, but it's able to depend on some sort of process to feed that data into the LLM context window to then generate the answer. And so that whole process is this retrieval process where you want to retrieve from the vector database to find a bunch of relevant documents, and then from there the LLM can piece together the answer.
So suppose I know, like say, hey, the answer is in my external document. What would be the best way to ask LLM? Say, hey, like the answer is from the external. Don't worry about the knowledge you learned, because I know like sometimes LLM doesn't really always follow the instructions.
I think some of the recent LLMs have been tuned to better follow instructions, and so we've noticed a general trend where especially if you use a more recent one, then if you just tell it like, try to actually use the information we provide and don't just regurgitate something from your own knowledge, then it typically obeys that pretty well. So if you tell it that, then it'll try its best to use the knowledge that you feed it.
Oh, that's great. So can you give some example, like what are the most recent model do this really well?
Yeah, I mean, even like 3.5 Turbo does a reasonable job at
Oh,
this,
okay,
GPT
great.
3.5. But yeah, some of the more recent ones like Claude 2, Claude 3, GPT 4. Yeah.
Great, thank you.
Keep going. Who's going to go next? Eric, you have a question?
Yeah, sorry, I was trying to find my own view. It's okay, see what I look like. Yeah, so I had a question about just the LlamaIndex, like has an entity and a company in itself. Like what's the I know it's like the framework itself is open source. I haven't used it myself yet. I've used the land chain so far, but like what do you see is like the how do you plan to, I guess, make it into a business later on? I saw there was like an announcement of Llama Cloud, but I didn't look into it. Like, could you talk a bit more about that?
Yeah, so Llama Cloud is a managed parsing, ingestion, and retrieval service that we launched a few weeks ago. And the idea is to solve your document RAG capabilities in a managed manner. So the open source is a very popular framework. It's probably the best at RAG in terms of production RAG. And then Llama Cloud is a layer on top of that for any enterprise looking to extract out insights from their like complex PDFs, build like a managed pipeline and not just through like notebook components, and also have like evals and observability. That's exactly what Llama Cloud is for. So it's like a kind of like a additional layer specifically for this use case of like document RAG.
Okay. And just for my own interest, you guys are you guys open to hiring people from Canada? Or are you only open to hiring people in the US right now?
Oh yeah, we have a few people international. Feel free to just if you're interested.
Yeah.
We have a careers forum, so feel free to sign up and we'll give it a look. Yeah.
Okay. All right. Great. Thank you.
Perfect. Any other questions? Llama Cloud was interesting, and you packaged the announcement with LlamaParse, so I wasn't sure, like, how is it related?
It definitely is related. I have an entire like enterprise slide deck. If you're an enterprise customer interested generally in document RAG, I can help present it, but I won't bore the rest of you guys. Yeah.
Okay. So eventually, I think enterprises, like everybody will try with their open source toolkit, but eventually they want to use something that's enterprise ready. So at some
Yeah,
point.
both from a system side as well as just like general good performance related. Like you want to actually parse out information in the right way and also make sure it's reliable, robust. Yeah.
Cool. Who wants to go next?
I just have a quick question. I've been using LlamaIndex for quite a while and was excited when you merged into LlamaHub stuff into there. Is that something that you see yourself investing a lot more in, like coming up with more and more APIs to, or whatever, retrievals from various systems? We use SharePoint, Jira, Confluence, and all those are things we want to pull data from. I just wasn't sure if that was kind of a core thing you're going to keep investing in or not.
Yeah, 100%. Everything in LlamaHub
Okay,
is
cool.
community contributed, and we're absolutely going to keep encouraging that. So we want to grow the hub of integrations. The community is like super important to us, and obviously our whole thing is like data and LLMs. And then in addition to that, we're like the more specific like enterprise related thing we're investing in from a first party is just like document parsing. And so I talked a little bit about LlamaParse, but we're investing pretty deeply in that aspect. But for literally like the entire ecosystem of data, a lot of it is driven by the community.
Maybe a question for both of you, Mark and Jerry. How to deal with hallucinations? Like, how do you evaluate hallucinations?
Yeah, Mark, do you want to take this?
Well, I guess in terms of constraining how the model can respond, so RAG is one of the approaches to limit that. They're being able to make calls to external APIs can direct the answers as well. But it's also something, at least I can speak for Google, one of the things in terms of testing the flagship models that go out, there's a pretty strong emphasis on that. Obviously, it's not a solved problem, but you see that if you were to compare models from a couple of years ago to the current ones, then the rate of hallucination is less. So there's part of it is the the model producers focusing on limiting hallucinations, targeting particularly where they can cause problems for customers, and also approaches like making external API calls and RAG as a way to kind of constrain the way that the model responds.
Yeah, so definitely echo everything Mark said. The only thing I'd actually add is, and this is a bit specific actually related to document parsing, is it's kind of interesting. If you take a really complicated document and then you mess up the formatting, then it's actually really hard for an LLM or a human to really understand what numbers go with like what text. So for instance, if you have like a table and then the parser actually messes up the table, then even if you have a really good LLM, the LLM will basically give you back the wrong numbers if you ask questions over that. And so there's some aspect where data quality still matters a decent amount. I think the better LLMs will generally be able to piece together like missing information, and so that data quality matters a little bit less. But even still, it's a blocker, and we've seen this pop up. There's just a lot of hallucinations if your data is like parsed the wrong way.
So the lesson is get the good quality data input, like pre-validate data before you.
Yeah.
Okay. Cool. So Curtis, you're polite. You had your hand raised for a long time, and I didn't see that. Go ahead.
Hi, can you hear me?
Yes.
Hi. Asked Mark and both presenters a question about how do they do QA testing? Do they do any, or they don't? And like what do they use?
So I talk so absolutely. I'd say there's a very strong emphasis. In fact, there's been some concern about the pace of release of flagship models. They've been kind of slowed down because there's been a high degree of testing. The approaches are different. So like Jerry explained, there's this black box in the behavior of LLM. So testing is a different approach than it's been before. And there's been learning going on about the most efficient way to do the testing, but absolutely, the models are tested before they go out from Google. And I'd expect, don't know the details, but expect that Meta and OpenAI, the other vendors that are putting out foundation models, are doing testing as well.
Do you know what tech, or you don't know?
I'm not going to talk about what Google does, and I don't know for the other vendors.
Okay, sorry. Yeah, the other presenter too, does he?
Yeah, I mean, I think QA tests. I mean, yeah, evals is a pretty big piece of most LLM application development. I think I had a bunch of talks basically talking about this, but basically, because you want to evaluate the quality, you need to measure the quality. You need to be able to define good evaluation data sets and a good set of metrics to test against. And all the parameters I mentioned in terms of RAG, like the data parsing, chunking, retrieval strategy, all of these are knobs that you can tune to try to improve the overall quality. So one way of thinking about LLM application development is reducing it to some sort of like data science problem. And to do that, you need good practices, tools to basically measure, evaluate, and iterate.
Oh, thanks, Mark and Jerry. Thank you.
Who wants to go next? Actually, Jerry, so while they're getting the courage and ideas, I saw your talk with Nir from OpenTelemetry. So it seems like OpenTelemetry is resurfacing as the way to instrument RAG pipelines, but it does not fully address evaluation. It's just tracing the calls like old style. So what do you see there? What would be the prevailing technology? How practical in the enterprise?
Oh, I mean, I think there's a big need for just like general tooling to enable developers for better and faster development. I think tracing is just one piece of that. So you can trace the calls and actually dig into like nested calls within it. You can also go in and, for instance, I think evals is another piece. So besides like tracing stuff, just like digging into evaluation metrics at each step. I think there's a lot of companies besides like OpenTelemetry and TraceLoop, and obviously there's like Langsmith, there's Weights and Biases, there's Rise. We integrate with pretty much all of these. So we're not actually necessarily building this first party ourselves, but we have really good partners in the space. I think in general, this is actually a top of mind thing that a lot of people think about. in terms of just like better tooling to enable development. Also, Daniel, I might have to drop off in like a minute or so.
Okay.
Just like a minute earlier.
Okay.
But yeah,
let's do one more question. I don't know who Moody has a
Nice.
question for. Devanesh?
Oh yeah, I had one question. So basically, like when I was doing a classification model from scratch using transformers, I used to do predictions and evaluations using Lime model to explain my explainability of model. But with LLMs, as it's a black box, is there any tool or any specific thing that can be used for as an explainability of an LLM model that how it performed well on the data that it was passed? Because currently we just pass vector stores, and when we do RAG or do a few short classification on top of it, we pass a label data to do a classification. But the underlying LLM, I just want to know if there's any tool or something that we can help in explaining the LLMs.
Mark, do you want to take? I actually feel like I have less insights on this space, but
No, go ahead, Jerry.
I think I actually don't have a lot of helpful things to offer because I used to work in like MLOps testing, so like traditional models, and we used to do like Shapley values and line and stuff. And so yeah, I totally agree. In general, I agree it's a more complex problem.
Text data on there, वो जरूरी है अपने को लगना पहले.
Sorry. Yeah, so I agree it's a more complex problem. I think you can observe the parameters. The input is unstructured text. The output is unstructured text. I think typically what I've seen how people usually evaluate stuff, right, is less like the importance and the like really understanding the interpretability of like the parameters, and more just using an LLM to grade itself as well as the retrieved context. So using a language model to it's kind of cheating, but basically using it to evaluate both the quality of the response, how relevant it is to the context, as well as like how good the like whether it's relevant to the question. And so we see people just like running very heavy LLM based evals to across like a data set and defining a bunch of metrics to reflect like different aspects of their overall RAG pipeline.
Okay, got it. Yeah, thanks so much. I guess that works. Yeah.
Great.
You unmute, Jerry. You have to go. You're muted yourself.
I might have to drop off. But yeah, really appreciate the time.
Thank you.
And thanks for having me on. Cheers,
Thank
guys.
you. We're going to stay on and
Thank you very
talk
much,
with
Jerry.
Mark. Thank you, Jerry.
Okay.
So
Thanks, Jerry. Bye.
Mark, so I have a question for you. Like it's similar topic. You wrote a book on the deep learning on structured data, so it's very relevant still topic. And then it continues with the previous question, like, do you plan, like, how do you see it in the LLM land?
Yes, this is actually came up. I'm working with Luca Masseron on a new book, actually, also with Manning. Just put a link to it in the chat on tabular, on the same topic, going a lot deeper and dealing with both gradient boosting as well as deep learning approaches to tabular data. So we worked on this book for a couple of years, and it, honestly was not exactly flying off the bookshelves in beta. So we had a discussion with Manning. We said, what we need to do is we need to add some generative AI to it. So we recently went through and added probably another 20% of material specifically on generative AI in both contexts. So in the context of gradient boosting as well as deep learning, working with tabular data. So some of it is sort of bread and butter stuff, just basically how you can use generative AI to make the feature engineering, which particularly on the gradient boosting side is pretty heavy duty work. So even ChatGPT out of the box or Gemini on the Google side can do a decent job helping to automate some of those things. And then there's some deeper kind of applications for generative AI as well. So it definitely is relevant. Now there's been some recent work specifically on generative AI, like looking at the problem of dealing with tabular data with generative AI, like looking at more kind of research perspective. There've been some interesting papers come out about that. We're not getting to that in the book. We're kind of a little bit more practical based, but it's an area where there's definitely interest. And kind of the theme of my existing book is, deep learning seemed to solve the vision problem, NLP, but was stuck with tabular data. And I think the needle's moved a little bit since then in the last 4 years, but nobody has managed to completely crack the code there. You look at Kaggle competitions, and the majority of the winners are still using gradient boosting rather than deep learning.
Thank you. Avinash, you still have a hand raised. Do you have another question or?
Oh no, sorry, sorry for that. Thank you so much. Yeah, thank you so much.
Any other questions? And while we're waiting for questions, like do the survey, like it's a bit.ly.slsto. If you add your name and email, we're going to do mining raffle. Maybe you can get Mark's books for free. I knew about one of your titles. I didn't even see this one. So thank you for sharing.
Yeah, Manning has a ton. I mean, there's just a plethora of books, and it's interesting. You think, 10 years ago, people would think, were people still going to be interested in technical books? But sometimes that's exactly what you need. There's a lot of material on YouTube and blogs, but having something that ties it together and tells a bigger story, and has a repo behind it with the code that explains it.
And there is one more thing. There is an early access program where you can chat with the authors like yourself. So
yes.
So it's you kind of participate while they're building books. This community loves Manning because they keep giving freebies like for every meetup we had, almost every meetup. And also like the reasonable price. For the same price, you get both the ebook and the print book, which is amazing. So unlike other publishers.
And one of the challenges with generative AI in books is it's just changing so quickly.
Yes.
If you look at where things were, even like that timeline I talked about, going back a year, it's kind of quaint. You think of where things were. It's just such a fast moving topic. It's difficult to get a book size 300 pages of content actually settled and current before things move on.
Correct. Hey, Kamal, I had a good comment to that too. So back to the Gen AI topics, like any other questions you have, like maybe on the topic open closed models, or like what do you think the future is going to be, like open source or?
I think there'll be a role for both. I think there were some people sort of making an argument. And look at Jan LeCun on X. He's a strong proponent. So he's been putting money where his mouth is in Meta, open sourcing everything. But I think there's a role for proprietary models that are hosted. It really depends on what somebody needs. And I think Google showed that by putting out Gemma, that people, for some applications, having an open model is the right fit. For others, people want something that's maybe a bit simpler. That's where you've got a managed service. You just basically have to hit an endpoint and you get what you need. Whereas deploying an open model and the care and feeding of it is a little bit more effort than it would be for an individual organization versus using something that's hosted.
Who wants to go next? Only the spammer was not shy. Everybody else is so quiet. Like I kept chasing these fake characters.
Has anybody looked at Devin yet? The news story that came out yesterday.
No, that's new. I wrote it down.
Well, it seemed to be the business press was saying, this is the end of software development. Again, I don't believe that, but there were some pretty spicy headlines about it.
I think in 2 years, most of our jobs will be gone. So, so which plus minus 2 years. I'm kidding. Pankaj, you're on mute.
Oh, am I? No, I wasn't really saying anything. But this Devin is I think nowadays the press releases are incredible. How fast products go from 0 to full 100 in no time. I'm quite curious to try Devin if it's possible, but it's not available yet.
Yeah, I guess you need to make the pitch, and you do that with when GPT-3 first came out. You needed to basically go and say, can I please get access to it? And sometimes that works. So when I got that, actually there's a YouTuber in Toronto who put out a video saying, here's how I got access, explaining how he got access to GPT-3. Followed those instructions and it worked. So I'm very, very grateful for that, because that was without that initial access and being able to play with it. It was, you have to wait many, many months before you can start to work with those things. So
on that note, like Gemini is now behind BART. But if I want to play with API, last week I still couldn't access it from Canada. It was wrong location. Like, do you have any?
Yeah, so Gemini is available in Canada. It is. So that's in the last few weeks. So it's only recently, but now you can get access to Gemini in
API
Canada
as well. So not just through BART.
Yes. Yeah, that's right. That's right. So you can get there are a number of ways you can get. There's the consumer Gemini. You get it through Google AI for developers and through Vertex AI, which is the hosted environment in Google Cloud.
I see. So Guys, come up with the questions. I will see how many of you did the surveys. I'm afraid to share now if the hack is going to take over again. Have you done the survey? It's bit.ly.slstl. And feel free to unmute.
I'm trying to look for the survey link again, but I think Curtis has his hand up. Curtis wants
Go
to
ahead,
ask a
Curtis.
question. Yeah.
Hi. Just curious, is there a difference between installing your own local LLM or using a web-based?
You get more flexibility. So if you install Llama 2 or Gemma or one of the Mistral models, you install it yourself. So you take one of those open models and install it yourself. You have more flexibility in how you tune it, and you can put it, have it completely within your own control.
Okay.
The downside is you need to have the hardware resources for the inference, and you've got to. It's up to you to maintain it. Whereas if you're using a cloud environment, you don't have as many options for tuning, but it's somebody else's problem to maintain it. And it's the same sort of advantages you get if you imagine having a database. You could have a database in your own environment, or you could have it as you could have it in a hosted environment. The hosted environment, you can scale. You've got all of the security advantages of a cloud environment, but you've got it maintained to a current level, but you may have a little bit less flexibility.
Oh.
And there's obviously the ongoing cost for having it in cloud versus having it in your own system. So it's similar kind of flexibility, cost, maintenance trade-off between using an open model on your own system versus using something that's hosted on the cloud.
Okay, thank you, Mark.
Mark, I have a question which requires a little bit of speculation on your part, but do you have any opinion on how the pricing is going to be? Because these are relatively new things. I still consider some of them expensive. And what do you see a year down the road, 2 years down the road?
I think there's going to be, so I think what's going to happen is there's going to be a certain commodification of some things. So there's going to be a sort of a middle level, not maybe the latest foundation model, but something that's a little bit, that lags a little bit behind, doesn't necessarily have doesn't hit the benchmarks for everything. So when I was talking before about people, what they really need is a minivan, but they're looking at Ferraris. So there's going to be a certain amount of that. I think, right now, I'll say right now, from the perspective of customers working with Google, people, a lot of times the question isn't so much price. It's, how do I want this. I want to have the capacity. I want to have the guaranteed capacity because I expect this to scale up. So, for some customers, really their concern is less price. It's more having a guaranteed throughput for a particular model. And then the other thing is the vendors are offering different varieties of models. So things that are maybe a little bit less capable, but a bit older, being cheaper than the latest state-of-the-art flagship model. So customers have choice. And ultimately, I think that's where it's going to come to, giving customers choice so they can decide that sort of performance cost trade-off for themselves, what meets their needs.
Thank you. It's going to be
I'm not sure if that's helpful.
To see how it
that's
evolves.
what I see happening.
I think more and more people are having to drop off, Daniel. So you should probably do the draw.
Yeah, we should, but we don't have many names here. I have only, let's see. I have
There's only 20 people left.
Okay, so let me paste. Let me try to share screen again. Hopefully you're going to see that. Share screen. Share screen number 2. And then let's do wheels of name. Is it moving? What's happening here?
I'm seeing your browser actually.
That's funny.
Oh yeah, I thought that's what you're trying to do is the browser. Yeah, it's the site's down. Maybe you need to randomly pick someone.
What am I sharing? Stop sharing. Let's do it again. I'll move this. I see now. I was sharing the window. Wheels of name. Am I sharing again? No. Start sharing. Okay. It keeps flopping. It's very, very strange. Stop sharing. Okay,
Yeah,
I will
Zoom
do
is
it.
having a lot of problems. Just spin it and
Yeah,
we'll take your
yeah.
word for it.
Okay, so so okay, let's see. I will tell you how many names I have in the raffle. No, these are the old names. These are not the names from this raffle. So let's do the form. While I'm doing this, do the form at the bit.ly, and I will paste the names from there, and then I will add everybody in, and you will be able to get Mark's book or any other product you want. So I'm going to Google Forms, and the names I see today. Let's see. So we have inside, I have Sanjay, I have Mark, Stuart, Tinin, Costa, Vlast. Vlast, you here? Devan, Kamal, Zori, Curtis, Eric. Anybody else doesn't have their name in? Mark, I'll add you as well. Anybody else wants their name? Hey, can you see me? I cannot hear anyone. Am I mute?
No, I guess that's it.
So let's try to do one more share, just in case. Let's see what's going to happen now. So you are witnessing screen number 2. Share. Can you see this?
Yep.
Anybody else wants their name in? Anybody else wants their name in? One. If not, can I spin?
Go for it.
Ta-da. Curtis, congrats. So how it goes, you're going to go to manning.com website, choose any product that you want, and then going to let me know. And I will connect you with Nice Falls for Manning to put that into your dashboard. That's how they call it. And then why not do another one? It's a 6-year serverless Toronto. So ready? Blast. Okay, but do not buy anything about databases. He's the database guru second to none. So perfect. Congrats, Blast. That is awesome. So I'll stop sharing. I apologize about the hackers and all the difficulties running the event.
There's nothing you can do about it. Well, thanks again, Mark, for joining us and presenting. That was awesome. And Jerry's presentation was very good, and he had to persevere through the no slides.
That was really impressive. Talk about grace under pressure. I think he did an absolutely fantastic job getting that material delivered in such a smooth way.
Absolutely,
really, really good.
Absolutely, yeah. No,
yes,
it was very
we'll
good.
have to practice this so it doesn't happen with a catch in May.
Well, thanks so much. Really appreciate the opportunity to speak. Thank you so much.
Yeah, Daniel, do you need email addresses from Curtis and Vlast?
I'll have to check, like, if they did a full survey.
Then it's in the survey form.
Yeah,
sorry.
so
Okay,
Mark, I know, but you can paste your email here, please, just in case if the form was not picked up properly. So that's all for me. So we can kind of stay if you want. We can go if you want. I know you had a long day, Mark. Thank you so
Yeah.
much.
I still have to drive home, so I'm going to drop. But thank you very much, Mark, and thanks, Daniel, for hosting. And we'll see you guys next time.
John, thank you,
Thank you.
Daniel.
I'll stay here, so whoever wants to chat.